Greetings and happy GIS Day. Thank you for joining us for Arkansas GIS Day 2020, presented by the Arkansas GIS Users Forum.
First, I'd like to start with a few introductions. My name is Chad and I am your host today, which simply means I am the person responsible for driving this thing, so if something goes wrong, I am solely to blame. Also joining us today, our team consists of our chair, Dino Trawick, also Sharon Hawkins, Daryl Allen, Paige Lott, and Brian Culpepper. Our agenda today looks like the following. After the welcoming, we're going to have a message from our chair, Dino Trawick, followed by a message from Esri about GIS Day. Then our first presentation today will be from Robert, Where to Find GIS Data, followed by a presentation from Drew Moffitt on high accuracy laser mapping, concluding with our final presentation on GIS touches every aspect of Central Arkansas water, presented by Alex Harper. We'll conclude today's presentations with a final introduction to GIS Activities in Arkansas, presented by Brian Culpepper. And then our closing. We'll be giving away a few prizes today. Also, at any time during the presentations, feel free to use the Ask a Question function located at the bottom right of your Teams meeting screen. We would ask that you focus those questions to the presentation being delivered, and they'll be answered towards the end. The prizes we'll be giving away today consist of 5 one-year ArcGIS for personal use licenses, and then 1 grand prize, an actual $400 value, a completely free registration to attend the Arkansas GIS 2021 Symposium to take place in Jonesboro next year. Now I'd like to introduce our chair of the Arkansas GIS User Forum, Dino Trawick.
Thank you, Chad. I appreciate that introduction. Thank you also for getting this going and your hard work on this. I want to welcome everyone to the GIS Day 2020. I want to start off by saying thank you for joining us. Our first formal GIS Day ever was in 1999. Jack Dangermond gives credit for Ralph Nader to actually starting this. Nader considered GIS Day a good initiative for people to learn about geography and the use of GIS. And he wanted GIS to be a grassroots efforts that was open to everyone. So from that beginning, it's turned into not just one day, but it's really a global movement. Brings universities, governments, schools, nonprofits, and professionals together to build knowledge of GIS in their communities. It also creates understanding about the world we live in. GIS Day happens because you and all of us have a passion for geospatial thinking. And through our event, it's getting that word out, and it's just getting the education and the knowledge into the communities that tells people who we are and what we do. So a little bit about GIS in Arkansas. So in the K through 12 education system, there's eSTEM programs. There's lots of these programs across the state, and they do a lot of great work, both in the communities and in their schools, just learning about geography and spatial interactions of what's around them. And then it progresses into the universities and to the community colleges and four-year colleges. And they also continue that education in more of a defined role, such as economics, agriculture, humanities, criminal justice, and many more. You look all around our state and you can see GIS used even in the backgrounds of things we don't consider to be GIS, but it is. So all the way from the federal government down the state government into the county, into the city, all aspects GIS is touched in one way or another. And I want to take this opportunity to recognize the leadership and the drive of the Arkansas GIS Board. and also the Arkansas Geographic Information Systems Office. They do a great job of helping coordinate throughout the state all the monumental work that users and publishers of GIS data that we put together and for all to use. And it goes back to the motto of create it once and use it many times. And with that, Chad, I would like to turn it back over to you. Thank you all for joining in and participating in this wonderful day to get GIS out into the communities.
Well, happy GIS Day to you, to everyone, actually. This is a special day. It's now in its 21st year, this celebration. And the idea behind it was to share and illuminate the incredible work going on by GIS professionals around the world to the rest of the world. So that means opening up and sharing to managers or your colleagues in other departments or in other organizations the power of what geography, geographic science, and GIS tools are really delivering in today's world. And they are doing an amazing job. They're responding to virtually every kind of activity. They're making things more efficient. They're making decisions better. They're addressing the big challenges like COVID this year, opening and illuminating the world's eyes to what's going on, how we're all interconnected. It's being used in fighting fires and disaster response and making cities safer and looking at how to organize our information so we can make better decisions in planning and in resource allocation. Anyway, you know all of that. This is the time to celebrate, to connect with your colleagues in other organizations, to share with kids in school, to inspire them to look to geography as a way to create a better world. Building the next generation is a part of the GIS Day celebration. Let me close by simply saying thank you for all of your work and happy GIS Day.
NEI is a Trimble geospatial distributor. We sell mapping, marine, and survey grade positioning products. What the Trimble brand means to NEI as well as to our clients is durability and innovation. Drop it out of the back of a truck, pick it up off the ground, put it back on your pole, and it's going to still work. That's what that means to NEI, and that's what it also means to our clients. One of the things that's given NEI the strength and confidence to go out and do our job every day is knowing that Trimble is 100% committed to its distribution. What separates Trimble distribution from other manufacturer distribution is the localization piece. NEI works from Louisiana over to Florida, up to Georgia, over to Arkansas. There's different problems in different regions that require geospatial expertise. So in order to deliver world-class geospatial solutions, we need boots on the ground in these specific regions to answer these questions.
Our backbone is customer service. It's been that way since the very beginning. Our father believed in that. William and myself believe in that. Our employees believe in that. Our teams, we have strong relationships internally and we have strong relationships externally. We're proud to be a family business, a woman-owned business, and to work with a partner like Trimble. We've come a long way together, and it's been an exciting journey, and we look forward to what the future holds.
So now I would like to introduce our first presentation, Where to Find GIS Data.
Hello, my name is Robert, and I'd like to show you how to find GIS data. I'd also like to teach you a few tips and tricks that I've learned over my 5 years. And there is a lot of data out there, and there's a lot of copies of the same information. And so you wonder, well, where do I get the right data? Well, you get it from an authoritative data steward. So it's really time intensive to make a data set. Data stewards typically have some kind of operational gain they get from maintaining the data sets. So for instance, county governments maintain tax parcels because they want to tax people according to the land they own. Arkansas State Parks maintains state park boundaries because it's the land they own. RDOT has their own state highways data set because they kind of want to know where their roads are. And the National Forest Service has trails that they want on their trail map, so they keep that. When I was a student, I really didn't think about data set maintenance. And even as an intern as well, I just completed a project after project and thought, hey, this is a cool data set. I'm going to use this. And I can continue to use the same data into the future years from now. That information is never going to change. But the more mundane reality of professional work is it takes time and energy to upkeep it. And it's important you upkeep the information because when information is incorrect, they're going to point it out. It needs to be current. And you need to make sure you have the resources in order to be able to maintain it in a way that is sustainable. Very often you'll find a certain group will make a copy of a data set that is maintained by its data steward and say, use this. But the problem is that data isn't being upkept at the same pace as what the data steward would. Sometimes organizations do one-time projects, and those are based on some underlying data set like parcel data or water bodies or elevation or buildings, and they don't really have any plans to maintain that. The data becomes less and less useful the more time that passes. That's why we rely on government agencies to act as data stewards to upkeep this information. There is a lot of redundant data out there. You might go to a website and you find 5 different data sets for hydrology and you're like, which one do I use? Well, I think an important thing to keep in mind is that generally information comes from a particular source. And this pyramid is an interesting way to think about it, that typically large federal government agencies, they get information from below them, from state and local. And the further you go down, the more likely you're at the true source of the information. Very often, stuff that is probably a little bit higher on the pyramid is actually derived information. Maybe something that was an analysis layer generated from something that came from lower down. An excellent example of this is in Arkansas. We have various counties that maintain tax parcel data, but that data is combined together at the state level to generate a statewide data set. Private companies like Garmin and ESRI generate base maps. That data doesn't come out of nowhere. It generally comes from government agencies that generate this information. If you're working on a project, you kind of have to balance some things. You have to balance the coverage of the data set. You might need something that covers the entire nation, and so it might not necessarily be as current as a state level data set, but you're willing to make that trade-off. And I think it's key that you have to know what trade-offs you're willing to make given how accurate or how current a data set is. Another factor of concern is resolution. Some data sets are specifically designed to be very low resolution because they cover a very large area and it's expensive to get higher resolution data. An important key is to read the associated metadata to be able to find out all of this information and make an educated choice on which version of a data set is right for you and your application. This is the first of the data sources, and the most important is the state GIS office. So not all states are lucky enough to have one of these. I remember when I was a student in New England, going to school with a lot of people from different states, and they do projects with data for their own home state. And some states didn't have a central repository. And their projects were a lot harder to do because they had to pull together data from lower resolution sources from the federal government, and it just made their jobs a little bit harder. So I'm really thankful that we have the state GIS office here in Arkansas. So why don't we go ahead and dive through their website. So here is the state GIS office's website. And then you scroll down, you see all these different categories of data sets you can download and mess with. So you can go into a category, for instance, water, and you could get some stream data and some water body data to use for your base map. When you click on any particular layer, you can see metadata about it, and you can download it, or you can connect to its REST API through Arc Server. So I'm just going to do a little bit of an example download here. I'm just submitting my cart. And in a minute here, I can then download a zip file of the shapefile. OpenStreetMap is a data set that is very important to me. OpenStreetMap is kind of like Wikipedia, but for GIS data. Anyone can edit it, and it has an infinite number of fields because it doesn't use a traditional model. It uses a tag-based model, similar to hashtags. OpenStreetMaps is a good data source for road data, but it's good for a lot of other things too. It started out as a project for building a global base map for road navigation with GPSs, but it's grown into something much bigger that includes things like land use and building footprints. And so if you're looking for a data set with global coverage, especially if it's a third world country that doesn't really have the capability to produce data of its own, then this is the data set for you. This is OpenStreetMap. You go to openstreetmap.org, you can see this base map, and everything that's displayed in the base map is editable data that you can also download. So as a user, I can actually pop in to the capital and go and actually see all that geometry and edit right here in my web browser. And the data set contains a lot of streets, especially for third world countries, and building footprints and footpaths, and anything else you can think of can be put in here. The regular downloadable source is GeoFabrics, but the problem is that, at least for people who use Esri technology, it's a different format. It uses OpenStreetMap's global file, and so you can download it for coverage for Europe or North America, but you have to convert it from a .osm file into a shape file and sort of extract the tags you're interested in, whether that be a particular class of roads or recreation features. You have to clean that after you've downloaded it, and so there is now an alternative. Esri has created its own feature service where you can dynamically link to OpenStreetMap, and it updates about every 5 minutes or so. And there's a real easy way where you can download select tags from OpenStreetMap like building footprints. And everything in here, those are all building footprints that you potentially could extract for a project of yours. And a lot of OpenStreetMap, the way it gets this data is through hot OSM. So a lot of people will edit OpenStreetMap just for their neighborhood because they want to, but some people use a program called hot OSM to generate data for organizations like the Red Cross, and it helps direct some of their operations with estimating populations and helping their volunteers navigate through countries without really established roads for their own routing purposes. So it is a crowdsourced data OpenStreetMap, but you won't find another data set with the same global coverage OSM has. Our next data source is National Map. So National Map is maintained by the US Geological Survey. Majority of their data either comes from other federal agencies or it's created as sort of a byproduct of the USGS topo maps. When I was a student, this was such a heavily used service that if you tried to download data during business hours, it would take a really long time. The whole system would be very slow. This is a really popular data source because it's fairly easy to find data, download it, and it has national coverage if needed. This is the National Map Viewer from the US Geological Survey, and the USGS produces topographic maps, and so a lot of these data layers located in here were originally generated to help produce those maps, or they were generated from old paper topo maps back from before everything went digital. So I can go ahead and zoom in to my area of interest, and then I can select my data set of interest. And the National Map Viewer is really good for elevation data. So I'm going to go ahead and select that. I'm going to keep the defaults and say Find Products. And now I see a single product. If I was in a large enough area, I'd see multiple. And so I can actually show the footprint of the particular imagery. And I can add it to my cart and download it similar to the way that I did with the state GIS office. So there are a lot of different products you can investigate. Elevation and contours are pretty big ones, as well as hydrology. And also the geographic names is pretty good for cartography because that is just GPS coordinates and the name of a location. So it has cities, towns, landmarks, something you'd love to see on a base map. Our next data source is the NRCS Gateway. So the NRCS is the Natural Resource Conservation Service. And what this agency does is it maps soil data throughout the entirety of the United States. And so they are the perfect source for soil and geology data. State agencies and some private companies might have more granular data, but NRCS has nationwide coverage in a consistent schema. Most of their soils data is actually non-spatial, but those non-spatial tables can be joined to their vector polygons. And so there is a lot of rich information in here, which you really need to be a soil scientist to fully appreciate. This is the NRCS Gateway site. If you click here on Get Data, I'll bring you over to their data portal, and this is a really old school data portal. So we have to select a state of interest, and we have to select county of interest. And if you're interested in a statewide data set, they do show up when you select the county, but majority of their stuff is organized by county. I'm going to go ahead and select Pulaski County. And then all the available data sets are listed. And most of these are redundant with some stuff on national map, like the elevation and geographic names, as well as government units and hydrology. But the soil is really more specific to them at NRCS. So I'm going to go ahead and try and download that. And it's just telling you a little bit about their process. I can click continue. And then this is a property of more of the old school data portals is you have to submit your email address, and then you'll get a download link afterward. So I'll go ahead and click continue. I already submitted one order, so that's already there. And the time in which you'll get that email will really vary depending upon how backloaded their request log is. So in my case, I got it within less than 5 minutes, but depending upon how many requests they have, it might take a lot longer. So I got a download link right here where I can download the file, and I've already downloaded a copy separately, so I can go ahead and extract that and extract it further. And we have a geodatabase, and we even have some metadata in here, which will show you how to use that shapefile and how some of this is defined. Our next data source is the U.S. Forest Service. They have a geospatial data portal that runs off of the ArcGIS Hub platform. It is a lot better than their previous GIS data hosting site. This is the data portal for the U.S. Forest Service. So it has everything organized by various categories, and also has a bunch of the different apps they have listed. So let's say I might be interested in trails. I can go over to recreation. I can see there, hey, there's the trails layer. And I can click on it. Gives me some metadata right here. Gives me a full list of all the various attributes, even related data, and I can download a shapefile from this site for my own use, or if you're so inclined, you can connect to its various web services for a dynamic link to make sure information is up to date. Our next data source is the U.S. Fish and Wildlife Service. So they have a number of data sets available for download on their website. This is the GIS page for the U.S. Fish and Wildlife Service. And at first glance, it doesn't seem like they have a ton of data on here, but you can dive a little bit deeper into it. For base map, we might be interested in wildlife refuge boundaries. We can click here for more information, and it'll dive you into some explanatory info. And if you dive even deeper, and you can see a number of different boundary shape files, which you could potentially download for your personal use. So there's a good number of these various data sets. The next data repository on our list is the US Census. So the US Census Bureau has a lot of geospatial data. You may be familiar with it as the Tiger Line data files. And that isn't the best source for national data, but it is a source. And the more important piece is census counts for population. US Census data can be tied back to a bunch of different geometry units, which can be displayed spatially. So you'll have to download these geometries and then find their associated tables and join them. Hello and welcome to the Census Bureau site for downloading geographic data. So if we scroll down, we can actually look and see census blocks and census tracts. So we can click there and download a nationwide shapefile or select the state we're interested in. And so for census data, it's broken up largely into 3 categories. You have census tracts, census blocks, and census block groups. And so once you have the geometry, then you need to tie that to a particular demographic factor you're interested in, like population or race. And the Census Bureau has a very new site for its tabular data. Previously, it was this really annoying site called Census Fact Finder. And this new site, data.census.gov, is a lot easier to use. So we can actually drop here and go to tables. And we have a whole list of different things we could possibly be interested in. I might be interested in total population. And I actually go in and customize the table. And I can select a different geometry. Say I want the tract or the county. I want all counties in the state. And I can actually then download data for every single county. And then because these are tied to a geometry, each of these has a geometry ID that can be joined to the census shapefile. And as you can see here, I have a population number, and I have a geographic name, and then it's geometry ID that can be tied to the shapefile. It also comes with a CSV that gives you the friendlier name for each of the fields. As you can see, those aren't user-friendly field names. The last major data source that I'd like to talk about is ESRI. So ESRI has a couple different data sources that are available, not necessarily all public. So if you have an Esri subscription as an organization, then you have access to the Esri Media Kit. And that contains a number of base maps with the associated data broken out, and I've used that before. as well as they have their Living Atlas. And the Living Atlas, believe it or not, but not all of it is under a paid subscription. Parts of it are totally free to the public. Parts of it are only available to organizations with maintenance agreements, and some of it consumes credits. But you'll find that the majority of products do not consume credits. So I'd strongly encourage you to look at it. This is the Living Atlas. So as you can see, there's a lot of different data sets that are available, some that you're very familiar with, like the world imagery, and some that you're might not be as familiar with, like world traffic. And as you can see, it'll list whether or not you need a subscription or not to be able to view this, and whether it comes from an authoritative source, usually from a government agency. And not all the content on here is actually from Esri. There is a good amount of content coming from various authoritative sources, government and non-governmental, that apply to be added to the Living Atlas, and ESRI reviews those requests and curates the collection. So there is a lot of information here, but there were some that I would like to point out. Interesting one is way back imagery. So we all like the world imagery, but wouldn't it be nice to look back in time at older versions of the imagery? You can with the world imagery way back viewer. So here's a prime example of how you might be able to use it. Here's the Broadway Bridge connecting Little Rock with North Little Rock. I can zoom into it, choose local versions of imagery, because it has a lot more than what's actually available in my area. So I can go ahead and select that, and I can choose the different years. So this is 2020, 2018, and then 2016. And oh, look there. I can see when the Broadway Bridge was installed. And I'm sure that a lot of you have potential use for this. And because this is all via ArcGIS Online, you can actually go ahead and open this in ArcMap or ArcGIS Pro. And I know a lot of us are used to doing that type of thing in Google Earth, but this would directly overlay with data you already have in ArcMap or Pro, rather than having to look in a separate program or convert things over to be able to view it. Interesting other thing here in the Living Atlas is Sentinel-2. Sentinel-2 is a satellite, and it takes, and the imagery from it gets updated daily. So if you need that high degree of temporal updates, you can get that in Sentinel-2, which is in the Living Atlas, which, from my understanding, it does not consume credits. So there is a lot of similar content out there that you might be able to get some use from. So go ahead and check it out. All right, this is the end of my presentation. There are a lot more data sources out there. I just picked out ones that I've found useful in the past, and most federal agencies do have some sort of repository or source where you can download their GIS data. Thank you for your time and attention this afternoon.
Okay, so this brings up our first Q&A session. I mentioned it early on, but for anyone that joined afterwards, you should see the Ask a Question button in the bottom right of your display screen in Teams. So if you have any questions, we would ask that you use that button and submit those now, and we will do our best to answer it. So our moderators that I introduced in the very beginning are online with me, and they would have been, I guess, reviewing the questions. And we will now turn it over to them to, I guess, post and answer your questions.
The first question that I have submitted, it looks like, is there a OSM to shapefile conversion tool?
All right, so I can speak to that. Can everyone hear me?
Yes.
Yes.
Okay, good. So with OSM, there's a bunch of different ways. The easiest one, which I specifically excluded, is there is one for organizations like the Red Cross that is publicly available that does rapid conversion, but that, because some people are relying on that for fairly rapid updates of information like building footprints for some kind of disaster that may be running in, and that is very time sensitive. I didn't want to necessarily share that publicly. The easiest way with Esri is if you consume their beta service, and then you can easily bring that in. There's another way, which I've done a lot in the past, is with QGIS. So QGIS has a tool for downloading localized areas. So rather than downloading the entirety of North America, you download a state or a county's worth by basically setting your extent. And then once you have that downloaded, it has some tools to convert the .osm file into a shape file. But to the best of my knowledge, there isn't a tool in ArcGIS Mapper Pro. I am aware of some discussion about Esri creating some kind of tool set where you could edit OSM data through ArcGIS Pro, but I have no idea what state that is in. And I'm guessing that Esri is probably going to get more and more intertwined into this. But I suppose the easiest way, if you're an Esri user, is to download it via the beta service.
Robert, we have another question. Ask if you edited or updated the OSM base features, and if so, how did you do that?
Right. So I have done that actually extensively, just for fun. And the easiest way to go about that is using the ID editor that's web browser based. And for areas with like moderate or low density of data, I found that to be very useful and easy to work with. You're working with pretty much the live global file. If you're interested in editing data that's really dense, it's really hard in the ID editor. So you there's an editor out there called JSON. I think I've used it before a little bit. Where you can actually download part of the global file, edit it locally, and post it, or even just edit your own global file locally and not ever bring it back down. And it is fairly easy. You can use any tag you want. And it's really easy to set up an account. You just create one, and then you automatically have an ability to edit. There is a set of tag guidelines on how to edit things properly. There's a whole wiki for that. The but the ID editor kind of funnels you to use specific tags, and it directly links you to their wiki page with the tag descriptions. So that usually is fairly straightforward. I think when it gets to row data and land classifications, you generally ought to refer to the documentation. Buildings are pretty straightforward, though.
All right. Thank you, Robert. Looks like our next question is, will this presentation or presentations be made viewable after today? I'll answer that one. The answer is yes. A few different, I guess, ways will be available. We're going to post this entire presentation video as a recording to our YouTube page, so it'll be available to anyone and everyone. It'll also be shared across our social media and email campaign, as well as all of the registered attendees will automatically receive an email of the recording of today's presentation to view again at their leisure. So looks like that's all the questions for this presentation. We'll go ahead, and up next is our first drawing for one of our ArcGIS personal use licenses. So to do that, I've prepared as generic as a way as we can come up with. So I have got the registration list here, and we're going to use a random number generator. And so we've got 2 through 105. And we are going to randomly generate a winner. So
this is
cross your
awesome.
fingers.
This is complete transparency. Love this, Chad. Good job.
All right. So our first lucky winner is row number 74, Vince Collette. Congratulations, sir. You have won a free ArcGIS personal use license. We will contact you after the presentation to get you your credentials. I would like to introduce our next presentation from Drew Moffitt, LiDAR from plane to PC.
LiDAR from plane to PC. The idea for this presentation is the result of years of working with LiDAR and creating LiDAR-based products for engineers and scientists. I realized there was a fundamental knowledge gap between the collection process and when it gets to our screens. Now, this isn't a technical talk per se, but rather informative, and hopefully you'll learn enough to come away from today with a better understanding of the data and how we as GIS professionals can use and educate others that use it. I would like to thank all of those persons and organizations who helped see Arkansas become one of the first states to have a statewide QL2 LiDAR coverage. Arkansas Game and Fish, AGISO, FEMA, NRCS, USGS with their 3DEP program, and others. If I accidentally left you off, correct me at the end. A little bit about myself. In 2004, I started at Camp Robinson, and I did not even know how to spell GIS. That is not a joke. Bo hired me with zero experience and I guess a great expectation of me either succeeding or failing. And luckily for me, it was the former. My first task was actually dealing with raw LiDAR. Bo had purchased a LiDAR flight, but he didn't purchase the processing of that LiDAR to any usable product. So this was 16 years ago, so the software was a little bit different than what we have available to us today to do this process. So I cut my GIS teeth on LiDAR. I've spent the last 16 years working with LiDAR weekly, if not daily, both from the Military Department of Arkansas to FDN Associates, where we used it for watershed studies, H&H engineers, biologists, and then for the last about a year at Garver, working with the Environmental and Planning Group in the transportation business line. The focus of today's presentation is on aerial-based LiDAR, but some of the concepts that I'll talk about can apply to stationary LiDAR scans or vehicle-mounted LiDAR collections. Actually, truck-based collection systems that departments of transportations are using for corridor collection are very closely associated with aerial-based because it's a moving platform. I'll talk through the process of collection all the way through to some of the uses for the data that I just don't think get enough attention. I wanted to include a definition of LiDAR so we can all have the same basis of understanding. LiDAR is a method for measuring distances by illuminating the target with a laser light and measuring the reflection with a sensor. So that's us actively shining a light and measuring the reflection with a sensor. The differences in laser return times and wavelengths can then be used to make digital 3D representations of the target. What that basically is saying is we're measuring the time it takes from the light to go from our emitting source, be reflected back and received by us, and we're making those timing details, and that gives us our distance. A few more basics to go over. LiDAR is an active sensor, like was just mentioned before. So think of a flashlight. We can turn it on and turn it off, versus passive, like a camera, where we are relying on another light source, like the sun. It usually operates in the infrared spectrum, although there are green laser LiDAR systems that are used to map bathymetry from a plane, but we're not going to talk about those today. It is scattered by fog, clouds, and rain, but can operate at night because it is an active sensor. And much more beyond this and becomes the world of PhDs. So for today's takeaway, it's a hyper-precise measuring tape using light. I included a diagram of a LiDAR sensor because I wanted to give you a better understanding of what is happening from the mechanical side of this. So in the middle, we have a laser source that is emitting a red light. That red light is hitting a spinning mirror, and that spinning mirror reflects it out into the world where it hits an object. And after it hits that object, it returns back in through this entrance mirror. This is a polarized piece of glass, hits that mirror and returns right past the laser through a filtered piece of glass to a receiver. On the right is a photo of a LiDAR sensor that is mounted to a plane, and we'll talk about some of the specifications of that particular unit in a little bit. The last slide before we get into the collection process is really about the etymology of the word LiDAR. So the word LiDAR is a combination of light and radar. We often refer to it as light detection and ranging, and this is based after more well-known radar, which is radio detection and ranging. As far as I can tell, there is no consensus, so be consistent. I use LiDAR in the lowercase form. The Oxford Dictionary supports this. If you don't like it, use a different spelling. But it appears that as long as you're consistent, everybody understands. So let's get into the collection process. The first step in the collection process is to get that LiDAR unit in the air. On screen, we have a plane, but the concepts we talk about work equally well with helicopters or UAVs. On this picture, we see coming from the bottom of the plane a red light pulse. That's that laser. It's not actually a solid beam, it's a pulse. And that pulse, depending on the LiDAR sensor, can happen up to several million times per second. That Regal unit that I showed before does this 2.66 million times per second. So this is a lot of data coming from the plane to the ground, back to the plane every second. In addition to sending out millions of LiDAR beams to the ground and measuring them back every second, the plane is also having to figure out where in the world it is via GPS systems. This is important so that you know exactly where that LiDAR recording is. The thing with GPS systems, though, is you have a plane flying at hundreds of miles an hour, trying to reference satellites that are moving at 2.4 miles per second, 12,500 miles above the Earth. So there's already a lot of complexity to this system happening. And the last component that is measured during the LiDAR collection process is with IMUs, inertial measurement units. So the plane itself is yawing, it's pitching, it's rolling, and all of those things need to be recorded along with the GPS location and the timing of all of those millions of LiDAR points collected per second. So how do we get a ground elevation point from a LiDAR reading? Well, for every LiDAR reading that comes from the plane, we know the plane's altitude. It's been corrected in its 3D space from not only the IMU, but also the GPS. And then we know how long it took for that single LiDAR beam to go from the plane to the ground back to the plane. And since we know the time and we know how fast the speed of light is, we can determine distance. So by taking the altitude and subtracting that distance as a function of time, we get ground elevation. This is a good illustration that puts everything together that we've talked about so far. We have the plane flying through space. We can see the pulses hitting the ground. I know I said and have used the term beam before, but really they're individual pulses. And you can see them hitting the ground in a zigzag pattern because as the plane is flying forward, the LiDAR sensor on the belly of the plane is scanning left to right, so that forward motion produces that zigzag pattern. That zigzag pattern is better referred to as a swath width. So on this screen, I have an image of some overlapping LiDAR collections where we can see the swath width is about 2,600 feet wide. That's going to be determined by the height of the plane and the LiDAR sensor itself. Basically, we end up with overlapping LiDAR points at the edges, and in the middle, where it's closer to the down center of the plane, we end up with only single points. The last item to think about is how big is that light on the ground actually? So how big is that pulse? Well, it's a function of laser beam divergence, and that's more thought about like if you have a flashlight and you shine that flashlight in your hand really close and that beam size is really small, but if you shine it across the room on the wall, the beam size gets really big. So the same thing is happening for our LiDAR sensor, but since we're so high, our beam divergence needs to be really small so that the area we light up on the ground is really small. So on the left, we have a plane that has a 0.7 milliradian divergence versus the one on the right, which is a 0.3. And you can see the distance difference in the footprint diameter from those two different LiDAR units. Let's move on to what is actually collected from a data standpoint for each pulse. For this pulse, there are 4 returns. The first return hits the top of the tree or the canopy. The second return is mid-canopy. The third return would be ground vegetation, and the fourth return is the ground. And you can see for the fourth return on this chart, there is a pretty high returned energy versus the other 1, 2, and 3 returns. This is going to help the software and the LiDAR vendor actually classify what is ground versus what is vegetation later. And we'll actually look at some of these examples of how we can tease out the data in ArcGIS Pro and ArcMap later. So putting all of what we have discussed so far together, let's look at an example forested cross-section. Note that we have a stream in the middle, we see trees, and we see undergrowth. Now let's move to what a simulated point cloud would look like if we were to look at this in software. We can see the green points representing trees or other vegetation. We see the tan or brown points represented on the ground. And notice how there are no points in the water. And that's because water absorbs LiDAR sensor readings. I want to move on now to a few examples of LiDAR cross-section areas that aren't natural vegetation. So this is the US 70 bridge over Texoma Lake. It's a truss bridge, and we can actually see the layout of that bridge on our screen now. We can see the bridge decking in that solid green. We can see the supports underneath it and the columns that go into the lake. We can see the superstructure and all the metal parts of it in the LiDAR itself as these upper oranges and yellows. And something else is pretty cool. We can actually see there's electrical systems that are offset cantilever from the bridge, and we can actually see those wires running across from left to right. This is an example of an overpass for the US 167 Arkansas 440 interchange near Central Arkansas. I included this because I wanted to show you that LiDAR only collects the top of things. It can't go through like bridge decking, like it goes through trees. This is not an X-ray machine. This is truly a visual line of sight type of operation. The last visual example here I'm going to show you is a LiDAR point cloud in ArcGIS Pro, where I have selected out for only ground shots. And we can see that there's a bridge deck here that is not being included because the LiDAR vendor had classified the bridge deck as a separate classification. Something we also don't see is water, because again, the water in general does not reflect LiDAR returns. Having all this data is great, but we really need to know how accurate it is and have confidence in that accuracy. The USGS has become the keeper of the flame when it comes to aerial LiDAR specifications. The goal for them as part of the 3-step process is QL2. And what does quality level 2 mean? It means that for every 2 foot on the ground, there's a point, and for every 10 square feet, there are 2 measurements. So it's important to discuss also, not only how many points are there, but how accurate are those points? As part of the QL2 specifications, non-vegetated areas, the vertical is less than or equal to 8 inches. In vegetated areas, the vertical is less than or equal to 12 inches. It's important to note that that's a difference. I do see many LiDAR projects returning 15 centimeter accuracy, which is about 6 inches, and that's good enough to generate 1 foot contours. So how do I actually get to LiDAR data that I use? Well, you can use the national map. I know AGISO hosts data, or in this screenshot, this is actually from the USGS's LiDAR Explorer, and you can get to this by searching for the 3-step LiDAR Explorer Amazon, or there's the link there, and I'll leave that up for just a moment. So the reason I like this particular application is it allows me to quickly define an area of interest and see what predefined DEM products there are, or what point clouds there are, and readily and easily download those. We've talked about LiDAR, what it is from a scientific standpoint. We've talked about LiDAR from a standpoint of how it goes on the plane, and we collect that individual pulse, what each of those pulse readings sort of mean. So let's talk through the post-processing in a very simplified form of how we go from the plane through the software to what we would readily download as a LAS or LAZ file. This is the most time-consuming part of LiDAR collection. Once the data is off the plane, the vendor will begin the very long process of taking the data from the various sensors like LiDAR, the IMU, and the GPS, and processing it to ensure data quality and to validate those results. There are a lot of steps here that are specific to each vendor. So we have the internal processing where the LiDAR is validated against itself, where we get a relative accuracy. We have external processing where we validate against survey locations. So targets are set out before a LiDAR flight that are surveyed, and then they're compared to the results of the LiDAR data to produce those accuracy reports. They do this in both open and in vegetated areas. So these two processes should be included with the LiDAR data deliverables as part of the metadata reports. Find them and read them, very important. And this is a very long process. For instance, I was recently working with some data that was dated 2019, but was actually collected in 2017, and I find this very typical. I've also read in sort of researching this presentation that there are 14 unknown variables that must be solved for each point in a LiDAR point cloud. So there's a lot of data they have to go through to really give us an LAS or LAZ file. Here we have a LiDAR acquisition and processing report. And the reason that these are important to look at is because they're going to contain information like here. It says, please note that water level differences will be noticeable along the flight boundaries between one date and another. This might impact how you actually use the LiDAR, so it's important to know that. Here's an example of a LiDAR accuracy report. It's important to find this because we're going to be able to go in and see that this project had a specified accuracy both in the horizontal and in the vertical component, and for the different types of surfaces, whether it's hard surface, ground, trees, or urban. And also the DEM. What does that DEM look like as far as quality as well? Something else that's going on during the post-processing is the point cloud is being subjected to classification in software. So for each vendor, this is a little bit different. So there's no direct comparison from LiDAR vendor to LiDAR vendor. But the output of this is a single point cloud that has multiple returns coded into it, so we can filter out ground or vegetation. The vendors are also going to create break lines, and this is for hydro flattening, so our water surfaces and our DEMs look nice and flat. The vendors are going to create those bare earth DEMs, and usually those are 1 meter, and those are averaged 1 meter. It's important to note. Those LAS files or LAZ files are going to be pretty big because they have hundreds of thousands of points that go with them. An LAS file is the LiDAR file, uncompressed, and an LAZ file, it's kind of like a zip file for LiDAR data. Usually when we think about LiDAR, we think about those bare earth DEMs. So how are those actually made? Those are made by the vendor in a process called binning, where the ground points that are classified from the point cloud are aggregated across a cell size, in this particular case, usually 1 meter by 1 meter, and they're averaged. The average method can introduce errors, and I will show an example of what that looks like, but it's suitable for most purposes, especially at scale. But we do get a loss of data quality. So if you want the best resolution for your LiDAR product, you go back to the LAS. So that error I talked about can actually just be a loss of data quality. So on the left, we have a 1 meter elevation DEM, bare earth. It's provided by the vendor, and the binning method was average, and that was specified in the metadata. On the right, it's a 2 foot. I processed this myself, and I used the binning method of minimum. Now, what we see between these two products is we actually see the stream channel show up. So I wanted the best, highest quality data, so I went and processed this myself, so now I could actually digitize those stream channels accurately. Here's an example of a potential source of 2 errors for a LiDAR product. We have a ditch that's full of water, and we also have extremely dense vegetation even during the leaf off period. So we're going to have a hard time getting true ground shots in something like this. So this is why I would process this area looking for minimum values if I were to make my own DEM. Post-processing final comments. Remember that each vendor is sort of like a black box when it comes to this. So find and read the acquisition and accuracy reports. Those are very important. You need to understand the data. Newer data sources are going to be generally better than older, and the LiDAR companies and technology are getting better. Water is not LiDAR's friend. It generally will absorb it, and dense leafy vegetation is not LiDAR's friend either. Remember, these collections actually happen during leaf-off conditions, but that doesn't mean all the vegetation is off the ground depending on the region of the US or the particular time of year it was actually flown. Using only the pre-processed DEM is like buying a Tesla Cybertruck to just pick up your dry cleaners. A lot of time and money was spent collecting a rich 3D point cloud. So to just use aggregated data is missing the full potential of the LiDAR. So let's talk through some more uses. I showed you this picture before, but I'm going to show it again because I think it's such a really cool and powerful example of what LiDAR can do. So this allows us to actually get measurements of complex features that maybe we can't get to, or give us a head start before survey data is available. We can actually get measurements of the bridge deck to the water surface. We can get measurements of the superstructure. We can get measurements and dimensions of the offset electrical lines from this bridge. You know, these are things that we can do remotely without ever having to set foot on the bridge itself. Each return reading is going to give us a relative strength of the return signal, and we call that intensity. We can see that on the chart with the red lines. So the first, second, and third return, their intensity is lower than the fourth return. The intensity of LiDAR returns can be used to generate monochromatic images like shown here, classify land use, or help us do permeable and impermeable land use analysis. Here's an image showing a full 3D point cloud being symbolized by elevation, but tinted by intensity. The intensity helps sort of bring out the context of the LiDAR point cloud because it's showing us where the roads and the asphalt and the trees are. They show up darker. Here is a real world example from a project I'm currently working on where the bare earth point cloud shown here and tinted by intensity will be augmented by survey information to create a 3D channel and surrounding areas that will be then used as the base terrain for a 2D hydraulic analysis. So these red dots on the screen are survey locations from physical surveyors. And I have a cross-sectional area that shows the draping of those survey points along with the LiDAR information. And you can see how closely those two match. And moving over to the bridge above the water, we can see the bridge decking way above at the very top of our little cross-section box here. And then we have some other readings in the middle, but then we have this solid reading of actual LiDAR points in the channel. So I'm going to take a wild stab here and say that the water was up and it was muddy when this LiDAR flight occurred. And underneath that, we have some survey locations along the bottom of the channel. So for this project, I actually went in and deleted those points that represented the water surface at the time of the flight and instead used the information from our survey. The last example of LiDAR point cloud usage goes back to the first cross section I showed you of vegetation. I've been focusing on showing you bare earth, but sometimes you might be after the vegetative cover. Here's a cross section where I've selected the ground shots in the low, medium, and high vegetation, and I actually classified these in ArcGIS Pro. So those LiDAR points that represented the vegetation can then be processed to produce standalone vegetation layers. This is a lot more useful to produce it in LiDAR in mass rather than having to digitize them manually from aerial imagery. LiDAR is complex and costly to acquire. It is a measurement taken from a moving plane thousands of feet up, flying at hundreds of miles an hour with a reference to satellites that are moving at miles per second, tens of thousands of miles above the Earth. It's basically magic. Its accuracy is defined. Find and read the acquisition and accuracy reports. Those are very important for you as a backstop to the products you create. It's a resource to derive measurements of roadways, bridges, trees, vegetation when you can't get a survey or as a precursor to a survey. Know the area you're working in. What is the local land like? Is it full of privet? Is it full of water most of the year? Is it pine trees? What's it like on the ground? And don't be afraid to go back to the LAS file and make your own judgment or products to fit your project needs. The DEMs that the vendors produce are fine on their own, but there's a lot more uses out there than just taking those. We'll hand it back over to the live version of this presentation for questions.
Thank you, Drew. Now I also actually feel like I understand LiDAR for the first time in my life. So, for those of you who may have just joined, if you are on Teams, on the web version at the bottom right of your screen, you should see a Ask a Question button. If you have any questions, we would encourage you to submit those now, and we will do our very best to answer them. Looks like there has been one so far already come through, so I'll read this first one. Question for you, Drew: is there an available source to view an already colorized LiDAR point cloud data set? Looks like either online or a download.
That's really going to depend upon who's making that LiDAR and what was in the contract that was specified. Most of the time for aerial-based LiDAR contracts, you have to colorize that yourself. Luckily for us, ArcGIS Pro and maybe even ArcMap, there's a tool to be able to use imagery to colorize your point file, but I usually don't see it for aerial LiDAR. For truck-based LiDAR though, I do see that. I do see colorized with RGB values. I assume that's what the question was for. I do see that for truck-based LiDAR though.
Okay, great. Looks like one more question here. If we have a metal canopy, how can LiDAR measure the distance to the ground below that canopy?
Well, it's going to depend where the plane is. Sometimes you're going to get lucky, and if the plane is off to the side, you're going to get a shot potentially underneath your canopy. I'm sort of imagining the way a lot of schools were built around Arkansas. You know, as a kid, you would have these canopies that ran from where the buses ran, some kind of like awnings. It's kind of what I have in my brain. So the LiDAR might hit the top of the canopy, but it might also hit the ground, and that just is going to depend upon the angle of the plane to the object it's measuring. If it's directly overhead, then you're not going to get a measurement.
Yeah, I may be speaking out of turn here, but it seems like I recall something, I guess in the ballpark of a type of oblique LiDAR capability. Is that something that you know of and could be used in an instance like this?
I have not ever worked with oblique LiDAR. It's not to say that it's not out there, but I have yet to really ever see a data set like that. I know they have oblique imagery, and we get those, like Google Maps is a perfect example of using photogrammetry to derive 3D point clouds from oblique imagery, but I have yet to see LiDAR operate that way.
Okay. Question from Andy. I see you use Global Mapper for some processing. Have you used the data to make voxel-based vegetation analysis?
No, I have not.
Okay. Well, that's all the questions that have been submitted thus far. We'll give it just a few more seconds here to see if anyone else has any other questions. Looks like a follow-up from Andy was specifically, I am interested in mapping trees.
So I don't use Global Mapper to do any LiDAR classification. I do most classification through ArcGIS Pro. They have some height-based classification schemes where you give it your point cloud and it knows what the ground is, and then you can say from 0 feet to 5 feet above the ground is low vegetation, from 5 to 15 is medium, and 15 to whatever your upper limit is high vegetation. So that's what I've used for vegetation mapping.
All right, excellent. Well, thank you again, Drew, once again, an awesome presentation.
Drew, one more question real quick. Is Global Mapper still free?
No, but it's significantly cheaper than your typical GIS. I think a license is around $1,200. And you can do a lot of LiDAR interpolation and working with that for that $1,200. But if you actually want to go more advanced, they do have a LiDAR module add-on. And that might be more towards what that question was related towards with the vegetative mapping of voxels with Global Mapper. But yeah, you can get into it for about $1,200 for a professional license, and that's what it is.
Thank you, Drew. That's really good.
All right. Well, now it's time to draw for our second ArcGIS for personal use license winner. I'll pull up our spreadsheet and our random number generator, and drum roll, please. Number 27, Patrick Haig. Congratulations, you have won your very own 1-year subscription ArcGIS for personal use.
Excellent. Chad, I was trying to give you a drum roll, but I was muted. Sorry about that, bud.
Maybe next time. Our next presentation is from Central Arkansas Water, entitled GIS Touches Every Aspect of Central Arkansas Water.
All right, hello. Thanks for joining me today. We're going to talk about how GIS touches every aspect of Central Arkansas water. Again, I'm Alex Harper, the GIS manager for Central Arkansas Water. I've been with CAW for 12 years in a couple various roles in the GIS department. I have a Bachelor's of Science in Spatial Information Systems with GIS from the University of Arkansas at Monticello. A little bit of info on Central Arkansas Water. We're a metropolitan water system, and we serve water to a population of approximately 500,000. CAW is currently in a core partner, is a core partner in a regional initiative to secure future sources of safe drinking water for the entirety of Central Arkansas. This map here shows in blue, our service area, our retail area. The areas in green, we actually wholesale water to, and we are ever expanding and growing. The Central Arkansas region is an urban area with a population of more than 750,000 people. So basically 1 in every 6 Arkansans benefit from CAW's essential and exceptional service. CAW has is driven by its strong mission statement, which is basically to provide essential and exceptional water service to the great people of Central Arkansas. But our GIS department also has a pretty powerful, or at least I seem to think we have a pretty powerful mission statement, and that is to empower others with high quality data. Not only our customers, but our internal customers are our main focus, the distribution staff, the guys in the field that really need this information, engineering, so on and so forth. And we have 7 highly talented GIS professionals in our section. There are several departments that utilize GIS, and when I say several, it's pretty well everybody. Basically, when I'm asked, how and who at CAW uses GIS, it usually takes me a minute because a lot of times, in GIS, we're focused on the task at hand and or the big project that's coming up, and we don't really stop and think about just who all inside our own organization or utility utilizes this amazing tool. But there's several, including GIS and engineering and distribution, watershed, customer service. I could go on and on. CAW currently has 3 water treatment facilities and 2 different water sources. Lake Maumelle and Lake Winona are water sources, and we have I think it's just over 2,700 miles of main in the ground, the service area of approximately 530 square miles, and as you can see, we have nearly 152,000 meters. That number changes daily, it seems like, but a big project that was undertaken was to GPS all of our meters, and we've done a really good job. I'm pretty sure most of them are GPS. There may be 5 or 6, I think was the number I heard the other day. So, we're ever expanding and growing again, and our GPS field data collector spends a lot of time out in the field, and as well as our other departments. But all specialized GIS departments need a really good base map, and I want to mention Pulaski area GIS real fast. PAGIS is a consortium of city and county public agencies that are governed by an interlocal agreement, and that basically serves as that base map data warehouse for the Pulaski County area. CAW is a member of that, and we by being a member, we get access to really high resolution data sets and tools at a major cost savings. We also, again, get that high resolution LiDAR data by going in with other utilities or city or county agencies to split that cost. We do a lot of data sharing with PAGIS. We share our water features out with the cities, the counties, wastewater, and vice versa. It's a really good, here in Arkansas as a state, we share data really good, but in the Central Arkansas area, we really do a good job of sharing data, which goes a long ways. Software, currently we are a little bit behind when it comes to, say, ArcMap or Server, but we have a lot that we kind of have to way when we go to upgrade. We have a lot of users, a lot of end users. There's CAW has just over 300 employees. And so, and a lot of those folks either have ArcMap or a legacy ArcEngine application. But you know, this is basically the Esri products that we're using on a daily basis, including Survey 123 and Collector, ArcGIS Online. We have several, you know, third-party vendors or partners with Esri that we have integrated systems with, or extensions. We use Innovize InfoWater for a hydraulic model. Our CityWorks is, you know, our work order management system. Our customer information and billing system is integrated, where orders are created in one and sent over to the other and completed and sent back. We have custom ArcMap tools and extensions that we've written in-house, or we've contracted out to have written. And then we have GPS on most of our vehicles out in the field. We're using Marshall's LIGO vehicle GPS for that. So a little background history on, you know, CAW's Esri partnership. Back in 1996, I believe, is when CAW, wasn't CAW at the time, it was Little Rock Water Utility, and then there was a merger between Little Rock and North Little Rock. But we will go into that history. But back in 1996 is basically when we started using Esri, and you know, our GIS staff would create the maps and print map books off, and you know, every truck had map books, and when something was updated, those pages would be updated and sent out, and it was just a sporadic update all the way up until 2008. 2008, we made this shift to get our field personnel, you know, actual maps out in the field that were somewhat live or a little bit fresher than those map books, and had more information. So we started using laptops running ArcMap or ArcEngine. We had a custom ArcEngine application at the time. And so all of that data was pulled locally to the laptops, and we had a weekly batch file that every user had to run on their laptop to pull that fresh set of data to their laptop to work out in the field. And you know, they would start working their work orders. We moved from a paper system to CityWorks to start using a digital work management system. And then it brings us to 2018 when we moved from laptops for our field personnel to iPads. And we have around 120 or so iPads out in the field, which have, you know, it has kind of pushed us to become more of a mobile friendly shop. Everything is live now with, again, our work order management system, which uses ArcGIS services and ArcGIS online web applications. So, you know, that's kind of where we're at right now with our mobile devices. We're pretty well an Apple iPad shop for our devices. Our distribution department, they really need the data. These are the guys that are out in the field. You know, they're on call. They get that phone call at 2 a.m. in the morning in the pouring down rain, and they need to know, you know, the location of a valve to do a shutdown or something along those lines. So they need, you know, high quality, near real time data right at the tip of their fingers, and this has really allowed them to become more efficient and you know, fix some workflows that had some efficient issues with, but as well as routing. I spoke about our custom tools and extensions a little bit before. Here's just kind of a screenshot of the custom add-ins that we have in ArcMap. Some of these add-ins we have had a third-party vendor recreate and to be able to be utilized in the CityWorks JavaScript map. But for the most part, our ArcMap extensions on the right side are the ones for editors that do some auto-populating of some fields, which I think there's a lot of new Esri extensions that when we are ready to upgrade, will take the place of these extensions that we had custom built many years ago. But a lot of these tools just allow the editors or the field staff or office users to have that data right at their fingertips. Couple examples of what these tools actually do. The upper left-hand smaller box is actually our calculate water pressure tool, where the user can click on the map and it will give them the calculation for whatever the calculated water pressure is roughly at that location. It gives them the pressure boundary that we have mapped out, the elevation and the static and average PSI at that particular location. We have a custom find feature tool at the kind of bottom left there, where the end user, if they know a hydrant ID, instead of using the straight up binoculars, and sometimes that could take a while, this tool will actually start populating a list as they start typing those ID numbers, just to make it a little quicker for them to be able to search on those. Earlier, I know Larry was talking about as-built drawings and stuff like that. We have a tool in our kind of add-in toolbox here where the end user can drag a box around the main, and we have the as-built drawings and other drawings that are associated to that main pop up in a box. If there was multiple TIFF drawings that were associated, you would see them and you could click on them, give you a little bit of information about it, and you can open that image. A lot of this information comes from our engineering department and their engineering database. Just whatever we can provide people, at their fingertips is really, really important. We also have what we call valve maps, but these are maps that are intersection maps that really give a detailed look at the water features, the valves and the hydrants from there's different measurements from the center line to curbs and stuff like that. Again, just the highest accuracy, highest quality data that we can provide these people out in the field is important. In the image to the left, you can see how we have some relationship classes and some other fields kind of set up for our hydrants. We have our hydrant inspections and our hydrant work orders. At the touch of a finger, you can click on a hydrant and you can pull this information up. You can see how we have our images kind of linked in with our with the different attribute fields, to where you can be able to use the hyperlink tool, or if you're on an iPad, we have it set up to where they can view the same exact stuff while they're out in the field, those as-built drawings. Like before, I was mentioning our vehicle GPS AVL that we have set up. It's integrated, and they supply us with a Esri ArcGIS service to where we're able to view our GPS, our vehicle locations. It really helps makes routing those trucks to emergencies a lot more efficient. So it's really a time and money saver, and it also encourages safe driving habits, because there's different reports that we can pull from that. But to be able to show them, live on the ArcMap map or the ArcGIS online map, or even our CityWorks map, is just very important, because we are all tied to the map, it seems like anymore. And some other little things, there's kind of big things that we do, that we provide data for and provide kind of tools for, things like our distribution department needed fire hydrant and valve inspections, and to look at some cost savings and some infrastructure replacements, and things like that. So our fire hydrant and valve inspections was a project that CAW put a lot of time and effort into planning out. CAW is like any other utility. We all have aging infrastructure. So we did a pilot study with a third party just to kind of see what it would, the cost analysis would be for them to do all of CAW's hydrant and valve inspections. Now remember, back to a slide before on how many hydrants and valves that we have in our system. It was that's a big undertaking. And so, when we compared the numbers, it was determined that CAW would save over $1 million by doing these inspections in-house. So to do something like that, the next question was, well, how do we set something like that up? So our GIS department set up a process that would symbolize all hydrants and valves based on the different inspection criteria that we had set up. So to do this, we had to utilize again our work orders and kind of determine when an asset was added to an inspection order type. The color of that feature would change nightly based on whatever outcome that inspection order had on it. And so, we had it set up that we wanted to make sure that each hydrant or valve was inspected within a 3-year period. And so this is how we set it up. We already had our work orders going. We just needed to find a way to do that. And so we have a really robust process set up now for our hydrant and valve inspections. Main kind of asset scoring, other cost saving analysis that is kind of done. This was an in-house asset management process that we had set up where condition scores and criticality scores were added to our mains, and as well as estimated cost to give an overall score for replacement. And it really kind of helps plan out the future infrastructure improvements that we need to focus on. Our engineering department uses GIS in many different ways, project planning and project tracking, as well as hydraulic modeling. They've recently started using iPads out in the field as well. This picture shows one of our engineering techs using, holding paper up or whatever. They can still do that, but they have iPads that they can pull things like that up on while they're out in the field as well. One of the recent expansion projects that we're still kind of looking at right now is in an area that the CAW has been looking to expand for to provide safe drinking water to for the past 30 years. This project consists of about 50 miles of new pipeline serving an approximate area of I think it's around 22.5 square miles. And as you can kind of see on the left map here, that CAW kind of has a hole in our system. In this project, by adding water service to this area would fill in that hole. So to determine the impact and design of adding this to our system, GIS again was called in to provide data and help perform different spatial and cost analysis in this West Pulaski area. There's a lot of different complications that go into a project like this. It's brand new. There's no real current infrastructure there, so everything would mostly be new. But just who wanted to have service and who's willing to pay a surcharge to get this dependable, award-winning drinking water that we have. So we had to get with our communications department and collect some addresses, and we plotted them out on a map, and you see a lot of points on a map, and sometimes it gets kind of hard to see what's going on. So we created a heat map in ArcGIS Pro to really visualize what the areas was going to look like. And so the real planning phase, it came for engineering to determine which area and zones to kind of tackle first and what the cost would be. So cost analysis was performed again based on a lot of different criteria that we had set up. And so if you want to know more about this project and kind of ongoing. Esri recently put out an ebook that references this case study that we did, and I believe at the Esri Infrastructure and GIS conference later this month, I think that there'll also be a video, a short 15-minute video about what all we've done with this project. Our maintenance department uses it for equipment change out, preventive maintenance, and kind of prioritizing the work around our different facilities. Facilities like our treatment plant. This is our Wilson treatment plant that we have mapped out. Not only, our horizontal assets, but our vertical assets too, that are stored by using tables and relationships built between the horizontal and vertical assets. Those vertical assets are really, really hard to draw on the map. And so this really allows us to be able to see, the relationship between, and kind of drill down to get to those features to create work orders on, or just to run some quick analysis on, some preventive maintenance scheduling and stuff like that. So, for example, a structure can have many different rooms, and these rooms can have many different features related to them, like mixers and feeders and transmitters. Everything is really stored in a table features, and everything is related back. So we have a lot of that built into our system there. Our watershed section or department, they rely on GIS quite a bit. Watershed is an important part to make sure that high quality water and the water source stays that way. So GIS is used in many different ways to track things that are going on in our two watersheds. We have two watersheds that we focus on. Maumelle watershed, which is about 88,000 acres, and our Winona watershed, which is just over 27,000 acres. Both are west of Little Rock and south of the Arkansas River. Big areas, and the watersheds are completely different. One, like the Winona watershed, is mainly surrounded by the Washita National Forest, and the same kind of goes with the Maumelle watershed, but there is some worry of development, stuff like that in the future. So we monitor a lot of stuff going on in those watersheds. The Maumelle watershed is traversed by an oil pipeline that is the pipeline of many names. It's the red line that's running to the north of the lake. It used to be the ExxonMobil pipeline. I think it was named the Pegasus pipeline, but this particular pipeline just kind of northeast of our watershed burst not that many years ago, and it the oil flooded out houses, and basically a whole subdivision had to be removed. And so this pipeline is very worrisome for our water quality folks. So we do a lot of inspections and investigating on this pipeline, especially since they want to try to fire it back up. The green and black dotted line that runs to the north of the lake as well is the Washita National Hiking Trail. So we have folks that are constantly out in our watershed enjoying the scenery. And CAW also has many different access points or parks in the watershed that we maintain as well. So to kind of add to everything else that we kind of do in the watershed, we track different forest stand information and different forest management events like control burns to manage and plan out what future events need to happen in these areas to make sure that we do continue to provide that high quality water and we keep any contaminants and things like that out. So to do this, our watershed staff has started using Survey 123 to track various inspections and various work in the watersheds, and actually recent discussions that we've had. They're really wanting to expand the GIS functionality that they have out in the field. One of the issues in this area, it's kind of remote. Cell phone service is not that great, so creating any sort of offline application that we can is one thing that we're gonna look into in the future for them. Different analytical looks at like slope analysis and things like that are looked at constantly out in the watershed as well. It's not just a cool map or anything. There are things that actually that are important, but they do make really cool maps. Underwater analysis, some bathymetric data of the lake, is looked at. We've recently did around our intake to see if there was some dredging around the dam that needed to be done. And by looking at this, it's like, well, we kind of need to update any data like that we have for the whole lake. So hopefully in the future, we'll be able to get the whole lake scanned and be able to have that to see what areas we need to focus in on for water maintenance. Our customer service and billing departments, the office staff currently use some ArcMap applications, ArcEngine applications, but right now our current customer service and billing application, you can only view or search on count table records. You really can't see that stuff on a map. We do have an integration again built between it and our work order management system to where things can be sent back and forth and stuff like that, but we don't have a true integration built between it and our GIS. So our representative, our CSRs in the office have to switch back and forth. Yeah, we all have multiple screens now, but it would be nice to kind of have a one-stop shop. So we're in the process of changing out our implementing a brand new customer service information system, and it will actually have a ArcGIS tab built right in that is set up using the ArcGIS online web map, and it pulls it right into that application. They can do their basic address searches, and there's plans on linking other information from the customer service information system into it. But having kind of a one-stop shop is big, and so this is scheduled to kind of go live sometime in 2021. Our department built a custom application, kind of a lightweight ArcGIS online web map app for our meter readers. This was to be used on iPhones or iPads or Androids, any device really. The meter readers have a handheld device. We were trying to get them on, to use iPhones to be able to read the meters. And so I built this web map application for the meter readers to be able to pull up that meter info that didn't just have the meter number or address or it had a bunch of other information. I can't really show the full application here because it has some information I can't share, but what we have learned though is not only the meter readers are using this app, it loads so fast compared to other web maps or even our CityWorks map. This one loads so much faster that everybody uses it as a reference. I've got a bunch of water features turned off now, but you can turn on water mains and stuff like that. And so it really brought to light, hey, we need to make more lightweight applications, something that will fire up real fast for the guys out in the field to be able to pull up some information. Everybody knows how to turn on layers now, but we really need that. The more of those lightweight applications. So hopefully in the future, that's one of our big goals is to work on more of those web apps like that. We're all living through the COVID-19 world now, And we've all seen some really awesome applications out there, like the John Hopkins application. The CAW had a kind of a different need at the time, and it still do. We needed a way to track our personnel. You know, how is COVID affecting our personnel? How many people are out, and so on and so forth. So when we started tracking that information, it was all done in an Excel spreadsheet, and I just knew there had to be a better way. So I saw some stuff that Esri had put out early on. This was back in April, and I know Jay can attest to this. I jumped right on it whenever I saw it to see how I could get this to work with what we needed. And so basically it's built by using a survey 123 survey, and that information is being pulled into an ArcGIS online dashboard, and the surveys are filled out by our supervisors. So they're filling out for their team, you know, how many's out, how many are affected, and all of that gets put in, and a grand total is created to show on the dashboard, and it updates daily. And our upper management really love to look at this just to kind of see what the daily glimpse of how it's affecting our personnel. We've been fortunate, knock on wood, that it hasn't affected as many as other utilities that we know of. But you know, there's another view of that where you can see a chart view on you know, how it's affected throughout the day. And again, management really loves to see this, to be able to show this, to make those decisions that they need to make. There's a map side of it that this information is pulled into. You can see how many people reported to that location, and how many may be out. Is that location open? Is it closed? Is it closed to the public, and stuff like that? So, you know, that another COVID or pandemic related thing is right at the beginning of this pandemic, it was decided that CAW was going to completely suspend any shutoffs, and we were actually going to go back out and turn water back on the folks that had been shut off. And so this was decided kind of spur of the moment type thing. We needed to do it over the weekend. And so we spun up another quick web map application. Normally this stuff is handled inside of our work order management system. Yeah, but a lot of folks that we pulled in to be able to accomplish this didn't have CityWorks or anything like that set up. And so the easiest, quickest way was to be able to pull a feature service from a save search on those work orders, and all the ones that were shut off like 90 days prior was pulled in to that save search. Those points were placed on the map, and our folks were able to go right to those locations, make sure nobody was left off. And I'm wanting to say, you know, I know within a day and a half we had them all turned back on, and that was roughly 500 or so that we had to turn on in one weekend. So that was a real lightweight application that you could see the updates happening live on the map too. It was really cool. But wait, there's always more. It's like the Billy Mays infomercial, but wait, there's more. There's many different departments that use what we do. We provide information for them. And, I know I'm leaving some off, but, communications, they hit us up for address lists all the time to be able to send out correspondence to. And we've done several special projects for our administration, our C-suite folks, just looking at future expansion out into the other water systems. Just looking at future buildings, future development, things like that. And I know there's a lot more that I'm leaving off, but just kind of hit on what we're going to kind of strive for in the future. But we have, many different things kind of lined up. We have a lot of upgrades that we know that we need to do to be able to utilize a lot of the new features that Esri has continued to put out. And the support that we get from Esri is amazing. One of the biggest things that's coming up for us is the Esri water outage solution and some sort of outage notification. What Larry was showing in his presentation earlier, I know I'm going to be hitting him up here pretty soon about, because what they're doing is where we want to be at. They're doing a lot of great things over there, and we're wanting to become more mobile friendly and get more mobile applications out for our field staff to use. So we have a lot of stuff on our plate, and we're looking really forward to achieving a lot of those goals. But in closing, I'd just like to say that, we're in the 21st century now, and GIS is much more than just a niche mapping tool. CAW is really proof of that, as we're using it in every aspect of our business operations. And GIS touches everything in such a dramatic way anymore. It used to be, okay, well, what does GIS show after all the other questions were asked? But now that's the first question. Well, let's pull it up. Let's look at it on a map. Let's see what it looks like. Feel free to save my contact info, reach out to me with any questions, and I guess we'll look for any questions now.
Rocket had previously had some CAD maps that were drawn of their system. When you really went out in the field and tried to look at where these things were located, it was pretty obvious that they're pretty far off. So in this case, we used an RTK Aero Gold. This receiver has a horizontal accuracy of 1 to 3 centimeters and a vertical accuracy of 2 to 6 centimeters. So these receivers Bluetooth to your device, and they actually come with an app that you install on your device that feeds the location data into Collector. And a crew of 2 were able to collect over 4,000 assets with centimeter accuracy in about 7 months.
Getting sub-inch real-time, no post-processing accuracy has now become a reality for everyone. By using the Collector, EOS, and LTI offset routine, we're able to deliver this project on time and under budget.
Our CEO is adamant about accuracy, and one of the big things for him is elevation. And I'm happy to say that the EOS, we can get centimeter accuracy or less on the vertical as well as on the horizontal.
It's my pleasure now to introduce Brian Culpepper to present a very special project that we worked on specifically for GIS Day. He's going to talk about a range of GIS activities in Arkansas.
Thank you, Chad. Well, thanks everyone for sticking around this long. Appreciate it greatly. And you may have recalled a survey that we had sent out earlier this week. We wanted, or actually it was last week, but we wanted to kind of share kind of what our GIS users are involved with around the state. So from that survey, we've compiled an application to kind of help us kind of review at least the top 9 attributes, or I should say activities, that have been going on within our state. And these vary from story maps to educational opportunities to some services that some of our private sector partners are providing. And I just wanted to kind of take a moment to share some of that with you all. The first one that we're looking at today is a story map that was built several years ago by Some faculty here at the University of Arkansas Fayetteville. Kendall Erdman led a team of students to conduct a research project and an analysis of kind of the history of the Russ mining town that is near our Buffalo National River. And for those of you that have ever canoed the Buffalo River, you probably know that the rush takeout is really the very last takeout in a canoe before you hit Buffalo Point and spill into the Whites. So this actually was a mining community back during World War I. I just want to kind of jump back here and let you know the years in which the prosperity was occurring. And so really it was the desire to have zinc and to support the war effort that was occurring. And since Germany was the primary source at the moment, the American zinc market stepped up. And this is an old historic photo of this mining village that was active during that time period. And now it's really just pretty much abandoned. There's nothing more than really a set of stairs that you can see as you drive past the gravel access road on the National Park Service property. And this story map, built by Kendall Erdman and a team of students, kind of summarizes what went on back in that map. And I encourage you all to kind of come visit this resource. I'll share the URL at the end of the presentation. But we have hyperlinks as well as a description of kind of what was going on, and you can jump straight to it. Moving on to our next example that was submitted, it was the National Weather Service briefing page, a nice dashboard that basically summarizes our activities and our weather that's going on in real time through a dashboard within Arkansas, and it provides some great infographics and multiple tabs for you to explore. We appreciate the submission of this, but you can essentially go look at one-day hazards. You can get a summary of live rainfall events and even a point-and-click forecast, as well as a situational overview. So very cool, very useful. Tabitha Clark provided that to us, and we certainly appreciate her. All right, so let me move on to our next candidate. We've got some city asset inventories that are being conducted by a private sector firm. I believe it's pronounced Half and Associates, if I'm not mistaken, based in Little Rock. And Sarah Wagner provided us with a couple of examples of the effort that they're moving forward and how they're using geographic information systems to maybe map tree inventory data, collect city assets, much like what we've seen earlier in Alex's presentation. And they have a complete QC and analysis customized form for they use within ArcGIS Pro. Now, also, Dino mentioned our GIS education and the K through 12 program called EAST, the EAST Initiative. And I had to share this submission from England, Arkansas, a small town just a little bit southeast of Little Rock, and kind of give you an idea of what these elementary students are attempting. They're just getting started in their GIS career. Their facilitator, Carmen Powell, is leading them in this effort. And what they're trying to do is help out a local farmer map the features, the wells and the risers and the levee gates within some of the farm fields in that area in the vicinity of England. So they're starting out an effort with Survey 123. They're building a form and they're practicing with that form in their schoolyard, remaining socially distanced so that they can perform that exercise. I want to jump to some community colleges around our state, and this one in particular is in Cossatot and DeQueen, and they've been using Survey 123 for a couple of years within their agricultural programs. Kelly Harris leads that effort, and in this case, she's developed a story map based upon her students' data, and those story maps are essentially a tree inventory, a digital leaf collection, I should say, that is a ongoing project each semester. They're also using the ArcGIS online platform to compile Survey 123 forms for timber plot field data collection, cruising timber, and this this right-hand side image here shows you the leaf collection that has occurred here in 2020, and that you can see there are 270 records total within this database alone. She's taken that data and the images captured by these students while they're out in the field and built a story map. And the link to that story map is embedded here in this application that we've dubbed the Map of Arkansas's GIS Day Activities. So I encourage you to go check it out. It's pretty cool. It's amazing what they're doing. They're also have built applications to support their soil collection surveys. The ag students get out and collect soil surveys each year. They send them off to the labs to get reviewed, and they analyze that data and store that in a database long term. It's another exciting project taking place there at UA Cossatot. Now, jumping over to UA Morrilton. Anthony Holt is a biology professor there on the campus. He's been introduced to the ArcGIS online resources. They've started integrating this into their biology classes, and he's become kind of a fan of story maps. And, you know, he's a biogeographer. He's essentially going out and doing a lot of cool research on a family farm that's over in Jackson County. And he's got this story map built, which I have the hyperlink to it included here, but just a few screenshots to give you an idea of what Anthony's looking to do. He's using this as a method to kind of train his students, keep himself fresh with the technology that Esri is developing, but he's documenting the history that has occurred within this piece of land here in the state of Arkansas. And he's documented this. It's very, very informative. It's got marriage license certificates, the history of the deeds and everything else from the property since the moment his family acquired the land. And he has a few anecdotal stories here about the flood of 27 and some of the stories that were passed down through generations. It's pretty cool. I highly encourage you to check this out. It's well written. It's great. All right, going back over to another great story map, which includes some video from the Broadway Bridge blow up back in 2016. And this is another great example of kind of how an engineering firm can use multiple technologies coupled with GIS to kind of help preserve some of our core infrastructure. In this case, it was some of these Central Arkansas water piping systems that were crossing the bridge to connect Little Rock and North Little Rock. But they document kind of how they acquired GPR data to help them understand kind of where the pipes were located to make sure they were not going to be damaged during the event. The entire story and the technology behind that is included in this story map. And once again, you can find it by navigating through this and also clicking on the More Information tab so that it'll launch the story map itself. You can jump right into the full story map and walk your way through it. And it's very, very informative. And you can play the video for the dud of an explosion that we had back during that project. And most of you that are from Arkansas are familiar with what I'm talking about. All right, now finally, I want to touch on another piece of Arkansas's history. Started out with the Rush mining town. Another one that is very informative, and it's kind of a sad part of our history, but it's a documentation of kind of the Roar community and the Roar internment camp that is located in southeastern Arkansas. And it's down in this area just north of McGee. And it is also a project that was a multi-organizational effort from Arkansas State to the University of Arkansas Fayetteville to a lot of historians, we have the hyperlink to the full website, which is titled Rising Above. This includes a documentation and archive of data, examples of work that was compiled during the time that folks were interned in this property, where they came from, most of them from California, starting in 1942. We discussed the history of the construction of the camp, the life in the camp, the residential blocks, and even when everyone departed in January of 1946. This is not all an Esri product, but it is very much a story map, and it's a piece of our history that we can no longer really, find out about, because essentially this is what the Roar site looks like today. There is a cemetery there, there's a monument there, not much of a town, but essentially we're right next to the Mississippi River levee north of McGee off Highway 1. Angie Payne kind of headed the team up at CAST to work on this, but it's been a multi-year effort, and the detail and the timeline information of all the documents that have been digitized are available for everyone to review. This is a screenshot of the Roar, or the Rising Above website, but all of these timelines are hyperlinked and interactive. And the coolest thing about this is really the visualizations. Angie and Vance Green and a multitude of other staff and co-workers at CAST and students have worked on reconstructing a section of this residential block, these barracks, so that we can interact with them in a gaming environment. And they built all of this within Unity. And I have to say, it's well done. It includes the original artwork that was created during this period. Those have been digitized and included within this this virtual visualization of kind of what life in this internment camp was like. And it's very informative, very useful. Quite honestly, we just found out 2 days ago that the 7th graders here in the Fayetteville School District are using this site as a resource to learn some more about Arkansas history that is not as well documented as it should be. So we were all pretty stoked to hear that, and very proud of the team. So I encourage you to go check this out. We'll share this in our informational feed after this meeting is over, or after GIS Day is over, and we'll make sure that you're all able to find this resource and see what everybody's doing around the state. As well as we encourage you, after today, you can click on this I button up here. There's a few details, and within this pop-up, we have a hyperlink for the form that you can actually use to submit your own projects. And we are going to open this back up after GIS Day so that you guys can contribute more and give us more material to share with others, so that we're representing all of the great work that our Arkansas GIS users are doing. So let me show you one last second here. I didn't show you the URL to this map of Arkansas's GIS activities, and this is it displayed on the screen. I hope you all can see it. And I apologize, Chad, I just forgot to show it to everyone.
Okay, absolutely.
All
and
right.
again, we'll be sharing this across all of our media outlets. If you're subscribed to our email, you'll receive this as well. All right. So now to conclude the day, we've got just a few more prizes to give away. Winners number 3, 4, and 5 are up next for the next ArcGIS personal use licenses. All right, so back to the random number generator. We will make our third drawing. Number 39 is Mary Lawrence. Congratulations to you. Number 4, number 73, Amanda Mann. Congratulations to you. And our final ArcGIS personal use winner is, oh, I don't want to mess that up. Cherry Smith. Congratulations. All right, time for the big drawing. The next winner will win one free registration to the 2021 Arkansas GIS Symposium. This is a standard $400 registration value. That winner is number 24, Daryl Allen. Congratulations to you, sir.
Hey, Chad, just run that one again since I'm on the committee. Don't, if that's all right.
Okay.
If that's all right, I'd prefer to see it go to somebody, you know, may be their first time on it or something.
Absolutely. Daryl is a part of our executive committee, has been for many, many years. So thank you for that, Daryl. Your contribution is greatly appreciated. All right, so one final time. Number 49 is Rusty Collier. Congratulations to you, sir.
Excellent.
So once again, we will be contacting all of you after today regarding what you've won. The ArcGIS use winners will receive a personal code basically to claim their license. That information will then be provided to you from Esri after you register the code. The Arkansas GIS Symposium winner, you will receive information directly from us with a certificate for that registration. So finally today, I want to conclude by saying this was actually the beginning, coincidentally, of our Arkansas GIS Users Forum educational webinar series. It just so happened to coincide that GIS Day was the perfect launch day or launching platform for us to begin this series. This is something that we have conceived moving forward, especially in the time of COVID-19, a way for us to continue our outreach efforts, continue sharing information with GIS users all across the state. So continue to look for more of these webinar events. They will obviously be much shorter, probably one presentation each, but on a much more regular schedule for the foreseeable future. With that, I would like to thank everyone for attending today, and I'd like to extend a special thanks to our sponsors, NEI and EOS, for their contributions, both past and present, and especially to ESRI for their contribution today of the 5 ArcGIS personal use license. Once again, we want to wish everyone a happy GIS Day. Thank you again.